Hello and welcome to another tutorial. So what we're going to be doing this time is we're going to be diving a lot deeper into assemblies, and in particular working with assembly definitions and some of the things we can do there with those in Unity. So we've touched on that a little bit from a point of view of using them for sort of addressing performance, and that's sort of one of the big handy uses of them. But we're going to sort of dive into that a little bit more this time and see some of the further things that we can be doing there with this. So let's dive right on in. So when we're talking about assemblies, assemblies are something that our code gets packaged up into. This is something that's part of the .NET framework system that Unity uses. So with that, by default, Unity is going to package all of our editor scripts into a editor-specific assembly and all of our runtime scripts into a specific runtime assembly. And what we can do is we can actually exercise a level of control over that. And the reason why we might want to do that is whenever I go and modify a script, every script in that assembly has to be compiled to regenerate that in order to be able to actually play our game. So if you have hundreds, thousands of scripts, which is very easily doable, if you have that many scripts, that means you make one small change in one, and now you have to recompile all of the code. So that can make our iteration times a lot slower, which isn't great. So there's things we can do to address that. So what I'm going to do is I'm going to actually create a couple of folders here. And I'm going to structure this sort of how we might potentially have things in our game. So we might have a common core that we use across multiple projects. And this is another area where assemblies have a really handy sort of just an artifact of how they work, is that they're good at partitioning stuff. So say I wanted to have a common core that I share between projects. What I want to avoid is things in that common core referring directly to anything in our game side scripts. So assemblies, by default, won't talk to each other, which is great. That means that we will actually get a specific prompt of like, oh, okay, no, these things can't talk to each other, so we have to architect our code better, which is great. So, okay, we'll have common core. I'm going to also have our game logic, essentially, or our game code. So I might call that game core. So the idea is common core would be something we reuse between multiple projects. Game core is something that's specific to this game. So I'm going to create a couple of folders here just for scripts. And I'm going to just create a script. And for lack of a better name for this, I'm going to have this be CC Game Manager. Actually, just Game Manager. Maybe Game Manager base, seeing as it's one that's going in Common Core. And then we'll set up our Game Core section. So this will be our Game Manager, which what we'll end up doing is making it inherit from our Common Core one. So we're going to create a folder for the scripts. So at the moment, these two could talk to each other happily. They're all in the same assembly. And we can kind of see some of the data for that. If we go and take a look in Explorer and we go up to the project, we can see assembly C#. That's the project file that it's generated for compiling our code. I'm going to chuck in a little bit of editor side code as well. So with editor, I'm going to then, I've got that editor folder, and this might be, for example, build tools. The content of these scripts isn't really important at this point in time. It's about just getting these set up. And what I'll notice is I've now got an editor one as well. So, because it takes everything in all of the editor folders and packages them together. So, okay, my common core, I shouldn't be changing that a lot during the game development. I would expect to not be modifying that a lot. So I want to put it in its own assembly so that if I make a change to it just needs to recompile that assembly. If I'm making a change to game code, then I just need to modify it just needs to recompile the game code. So how I do this is I go to the top level folder where everything underneath that I want to group into one assembly. Then I can right click, I go to create, and what I am creating is something called an assembly definition. And then we give this a name. So common core. So when we've created that, there is a bunch of controls that we've then got. So we can control things in terms of whether it's going to automatically pull in references to things. So there's a lot of fine-grained stuff we can do if we need to. We can also indicate particular platforms that this applies to. And there's also some pretty cool stuff we can do with version defines that we'll have a look at in a moment as well. So now that common core, everything in this folder is based off of that. Now in my game core, my game manager here, let's say I want to have this based on that one from our common core. So we're going to write the code exactly as I would normally expect to be able to do this. Game manager base. So we can save that. And that still all works. No issues there whatsoever with that. That's still going to work entirely fine because by default, all of this code here is still in that sort of global assembly that gets put together, the kind of kitchen sink assembly is one way to look at it. So it's not going to have any issues with accessing that. Any custom created assemblies, it automatically can reference. If I wanted to restrict that, so I wanted to control what assemblies it's pulling in, I can do that. So what I could do is I could again set up another assembly definition, and this could be called game core. And again, because what we could do is we could have our common core code, then we could have game core that's kind of a thin layer of common stuff that's used in a lot of cases, and then specialize further. Because again, if we have lots and lots of files that might be just in our game logic, we could set up assemblies to partition that, which is going to mean that, okay, say I have, 100 AI scripts, I can set up an assembly just for those scripts, which then means that when I change an AI script, it just rebuilds that assembly. It's not going to go and rebuild everything. So we can use this on a finer grained approach if we need to, if we're starting to get a lot of systems there. But we'll notice as soon as I've put it in another assembly, it can't access it. And this is something that if you're converting a body of existing code over, you'll quite likely run into, because you might be using things like Cinemachine, or Timeline, or the new input system. And as soon as you set up your assembly definition, you might see a whole slew of errors appearing. And that's okay, that's to be expected, and we can fix those. Because what I need to do is I need to tell this that game core, it can and should reference our common core. So over here with the game core selected, you can see it's got these references. So what I would do is I go add, and then I can select, and you can see here a whole bunch of our different ones. So if I did want to bring in stuff like, editor coroutines, if I wanted to bring in TextMesh Pro, so we can indicate the particular ones that we need to. But I can also indicate that common core one, and then I can say apply. And we'll notice recompiles, because it makes sense, it has to, and that error is now gone. So we can indicate the particular ones that we are working with. Now, we can actually end up with a little bit of an issue. Now, we're not going to see it just yet, but if I go and modify this code, so we're going to let it reload. so I'm editing the code that's in that editor folder. So using Unity Editor, and I could be doing any particular stuff in here. It doesn't really sort of matter what particular thing I'm doing in this. It's just about making sure that I'm doing something with the editor. And I don't even necessarily need, probably, to write any particular things. I could potentially have some logic there, but likely just doing the using may be enough to cause the problem that this creates to appear. And this is the thing. This setup that I've done here will have a problem, but I won't see that problem until I go to build. Because what's happened, those editor folders, so normally Unity will go and grab the content in each of the editor folders in the project and combine that together in that separate assembly. But because I created an assembly definition in a parent folder, that overrides that behavior, which means my editor code here is currently put into an assembly that would actually be included in a build, which is a problem. So if I go to build settings, I'm going to just try and tell it to build. That's all I'm going to do, is just tell it to do a build. And I've only got a using, so that may not be enough to actually cause it to break. So that alone doesn't cause it to break. But if I actually set this up, so, okay, well, maybe this is a editor window. That should be enough to actually cause this to break, because we're directly now referencing something. Now, I might need to have it that I've got code particularly referring to it, but I'm guessing probably having it be an editor window will be enough. Because and it is. So this shows the problem. So this is a really subtle one and is a very easy one to miss the problems that this can create. So we need to go and look at how we can address this. And it's actually pretty straightforward to address this, because we can quite easily set up, similar to what Unity does, where we pull everything from the editor folders into their own assembly. So first what I would do is I would create a folder here called editor, and I'm going to create an assembly definition under that folder. I can't create it at the same level as another one. That's a restriction that exists, so you can't have two assembly definitions at the same level. So I create an assembly definition here, and I'm going to call this Common Core Editor. And then the list of platforms here, I untick any platform, I deselect all, and then I can tick Editor. Now, with this, it would also be useful for it to bring in, most likely, I'm going to need it to refer to the Common Core code, which is okay. I can bring in Common Core as well and do apply. So, okay, that's the first step. That still hasn't fixed the problem yet. So one of the things we can do is we can actually pull code from lots of different locations into an assembly. It doesn't need to just be from within a child folder. So it doesn't need to necessarily, just like we've got the assembly definition here, we can pull things into that assembly definition from different locations. So it could be, this would be very bad to do, and we shouldn't do this, but we could pull in code from the game core folder into the Common Core assembly if we wanted. We're not going to do that. That would be very bad to do. The main time we would want to use something like this is, for example, what I'm going to do with this editor code. So what we would do is in each of the editor folders that we want to be essentially transplanted into this other assembly, I go to those folders and I create an assembly definition reference. So I would call this Common Core -editor. So I'm following the same naming that I used here. then that reference, I select that assembly definition and go apply. Now this, I can copy and paste that reference into any editor folder that I have then. So, say this was our, let's have a miscellaneous folder, for want of a better name for it. I could put that stuff in here. I could also have, for example, I might have a audio folder. So under that audio folder, I could also have an editor one. And that, say I needed to have that editor code pulled in, I would take this, can copy it, and I can paste it in here. So any of the editor ones that need to go into that common core, I can work with them just like this. So now if I go to build settings and build, and select the particular folder, this time it will actually be fine because it knows how to grab the code that's for the editor, extract it out, and it doesn't try and actually combine it into the particular build. So this is really handy. This gives us a way that we can sort of split stuff up, and we can still pull things in from different folders if we need to, and we start to get a lot of control over how we organize and work with things in the project, which is great. We can do more than this. So one of the things we can see with these assembly definitions is, apart from having things like bringing in these additional references, which, as I said, if you're using things like Cinemachine, Timeline, New Input System, if you've added in different plugins or other packages, you will likely need to include the reference here. I would generally assume that anything that is a separate package, you would need to add it in as a reference if you are working with that code from within anything in the assembly. So that's something just to be aware of. And it's pretty straightforward to find them. I generally don't try and add in any ones initially. I create the assembly definition and then I look for the errors. And as it breaks, it'll tell me, oh, okay, I tried to access Cinemachine. Okay, cool. Find Cinemachine, add that in. And add in each one until the errors are resolved. So that's how I sort of usually approach it. That way then I'm grabbing in only the assemblies that I need to. So we also have, and this is a really, really useful thing, these version defines. So if I add an entry here, what we're able to do is some pretty cool tricks, really. So say I'm using our version defines here under select. You'll notice here it's listing Unity and it's listing a whole bunch of different packages. So what I can do is I can actually check the version of these. So I can write something here, or say I select Unity. Then what we can do is we can create a define based upon the version of something. Where this can come in really handy is if your code needs to do different things based upon the version of Unity or the version of a package, which can be the case because interfaces, things like if that sometimes change. So we need a way to be able to detect that. So these version defines allow us to say, okay, well, Unity, I might want to have a define that, for example, actually, we could have it be Unity version 2022. And I can indicate the expression here. And these expressions can get quite sophisticated. So we can check and what we're checking here is the version number. So for something like Unity, I can actually get super, super specific. And I could be writing 2022 point, let's use the one I'm currently using, 1.6, F1. So I could check, is the version after that? I can write more expressions than that though. If I say wanted anything that is, in the 2022 series. I can check that. Maybe I want to check specific versions within it. So 2022.1 to 2022.2. So this is going to grab me, it's going to define that Unity version 2022 if the version is less than or equal to 2022.2.0, or, and also that it is greater than 2022.1.0. So it's going to check that it's inclusive. I can also change that. So I was using square brackets, and it's really subtle here. But if I use rounded brackets, rather than being inclusive, it becomes exclusive. So say I wanted it to be a version that is before 2022.3, then I could use rounded brackets. Same thing here. So we can mix and match these. So that's really handy for what we can be doing there. And you can sort of experiment with different ones that we could be doing. So we can't do something like a less than or equal to. That's something to be aware of. We can try other mathematical expressions, and so that's an important thing just to see the kinds of ones we can use. And it's largely our parentheses are sort of the main things that we can actually use. We can do a check for a specific version. So if we use square brackets, then this is something where it has to be equal to exactly that. You can try that with rounded brackets, and it won't be valid. So these are generally for checking sort of version ranges. We could try having an empty bracket, and we can see that won't pick up anything there. So if you're wanting to check version ranges, you're kind of needing to look, is it between particular values? Is it greater than values? That's generally what we're having to do with that. Now, in terms of what this actually ends up doing, so I'm going to put this, so it has to be 2022. So any of the, this should match then any of the 2022 versions. So if I do this, then what I'm going to do is I'm going to apply that. And I'm going to just go to the scripts here. So we have our game manager base. And what this allows me to do is that setup that I defined here. So this common core, that here, I can grab that, and I could be going and checking if that. So this would allow me to do something specifically if that is defined. So that allows me to check, is that particular thing defined? So let's test out with this working. I'm just going to mark this as protected and virtual so that in our game manager here, we can do a protected override, seeing as we are inheriting from it. Just run these. Because what I want to do is see what happens then when I run this. When we run this, it's going to run. We don't see anything. But that's because if we take a look at this, it's checking that it has to be exactly 2022.0.0, which is not what our version is. If I want to match anything in the 2022 series or later, then I can do just the version number there, so no square brackets around it. So let's run it with this instead. So with this, it runs and I get the message appearing. So this can be really handy. You can set up a lot of different ones here. So if you've got something where you want the common core to potentially work across different versions of Unity, you can configure some custom defines here in your setup. And we can set up a lot of different ones. We can be, as I said, checking all different versions of packages here. And we can set up lots of different ones that we have. And this is really handy because some things there might be a version defined for. There are for some packages, some versions of Unity, there are version defines that you can query just with those hashifs. But they're not always there for everything. So this gives us a way of setting up something so that it's there for any of the particular packages, which is really quite handy. And we could do the same thing in our game core if we wanted. And what we'll notice is all of the Unity ones will appear here, but our Common Core one doesn't. So we can check Unity, we can check any of the different packages, but it's only going to be checking the Unity particular ones. So it's just something that is a bit of a limitation with it to be aware of, that it is only going to pick up those ones. So the other thing that we can do is we can also set up constraints. So what these constraints are is just like here, we're defining a particular symbol. So these are a scripting symbol that is defined and is valid there within this code. So that's an important thing. These symbols, this one that it creates, is only valid in scripts that are part of this assembly. It's not valid outside of that assembly. But we can also say that an assembly only gets included if we have a particular scripting symbol defined. So say here, I could set up use common core. And what that's going to mean is unless this constraint, unless this scripting symbol is defined, this assembly won't get included. So if I do apply, then I immediately get errors because I haven't defined that scripting symbol, which means this assembly doesn't get compiled. So this is something where you could have stuff checking for particular platforms, stuff like that. So that can be a way of having this only be applicable for that. We do have our platform settings here, but you could also have scripting symbols that it checks for there. Now, to define those symbols, if I go to Edit and Project Settings, then we can also just search for, our symbols. And where these will be is they're under our player settings. And you'll see here these scripting define symbols. So I can go and add, and then I can add in that particular one and then do apply. Now you see it's recompiling the scripts down here, and it will get rid of those errors because it now knows that that's included. So the errors have gone, it's got that included. But those scripting symbols are defined based upon the particular platform typically. So if I switch this over from Windows to Mac, so I'll switch it over so it thinks we're working for doing a Mac build. Then it has to go and run through doing the usual sort of code importing, everything like of that. And if I go to the player settings, you want to make sure you go and check that these are still actually defined here. That's something where they ideally would be, but the only reason they are in this case is because I'm still on desktop. You can see here, dedicated server settings. Okay, still got those, but we could easily end up with a mismatch. So we're lucky in this case that we've got the setting there for both, but that won't always necessarily be the case. So if you're working across multiple platforms, do make sure you check that those symbols, if you're needing them defined for each platform, that they are actually defined for each one. In this case, I'm kind of got lucky because of the fact that Mac and Windows are considered just both the same desktop environments, so everything there was the same. that won't always be the case. You will have at times where there is stuff that is defined only for iOS or only for Android, only for WebGL. So do make sure you go and check that if you're doing that with the assembly definitions. So that's pretty much the core of what we're able to be doing with assemblies. The other thing that we can do, and we did sort of touch on this, of having sub-assemblies. So I might have a miscellaneous that I'm going to put in there. I might have a AI folder. So in that, I'm going to just set up, let's just create a simple AI manager. It's not going to actually do anything, but we just want the script to be there. So at the moment, all of these get bundled into the one game core. What I can do is I can actually split this into sub-assemblies. So I could have under this a assembly definition, and this would actually be our game core AI. And then I could do same thing for the miscellaneous stuff. So this becomes game core miscellaneous. So we have separate sub-assemblies. Now we'll notice we do have to go and make sure we update what things it's going and pulling in, what things it's sort of referencing. So we have to do our same sort of setup. So common core, and we can apply that. So we'll see we do get a bunch of errors, and that's because if we go to our one here, we again need to tell it that it has access to our common core. So bring that in, and it's going to again reload everything. So that's good. We've got everything updated there. Now one thing we'll notice with that is it does then alert us that it's not going to compile this because there's no sort of common scripts, and that's fair. If we had everything just in its own separate assembly definitions, we wouldn't need that game core one. That game core one is only really going to grab, say I set up one here, it might be main menu. It can grab stuff that is not included in its own sub-assembly. So it is something where we might not sort of have a need for it, but it is something where if we do need to, we can go and set that up, which can be really handy. And we can just confirm that that is sort of working nicely. What I want to do is in the main menu here, let's try and do a find object of type for our game manager. And I'm just going to do this. So it's going to be grumpy at us, which is okay, because this is something that we're going to need to be able to resolve. So, okay, well, it's in game core. Game core probably needs to refer to things like game core AI and game core miscellaneous. So we might have cases where we need to start sort of bringing in multiple other assemblies, things like that. And that's okay. Allows us to keep everything nicely partitioned, and we can see we've resolved all the errors. So we've got our approach now that allows us to take our code, to organize it in a way that means there's a much smaller amount that it needs to compile. Now, in terms of how you should approach this for development, one of the things that I would recommend is don't initially sort of go just all in on really sort of micro setting up hundreds of different assembly definitions. I would very much not do that. What I would do is I would start out with just a few ones, maybe 2, 3 at most, at the very top levels. So your core code and your game code. That is as far as I would go initially. And then when you identify areas that are quite large, that have a lot of scripts, then you can look at splitting those up into smaller ones. Because as we do this, that creates, we're kind of creating sort of walls between our code and little sort of specific tailored bridges between them, which is good for modularity, but that can end up becoming a little bit of a nightmare if we're not cautious. So we do want to exercise a bit of restraint to begin with, in terms of we make careful selected changes. We update a couple of ones to using those assemblies. And then as we're going through with development, we evaluate case by case. If we start to see that our compile times are getting quite large, then we can look at splitting things up. But otherwise, we just keep it fairly simple. Otherwise, it can really create a bit of a mess, and we can end up sort of having to fight against the partitioning there. So do avoid just going and putting an assembly definition in every single subfolder. That would be really bad. Use them sparingly and use them where they're going to give you a good advantage. In sort of most of the projects that I'm working on, the size and scale there would have maybe 2-3 assembly definitions at most. And the main reason for those additional ones is I would generally have Common Core code, Common Core editor, game code, and game editor side code. So maybe 4 at most there. If there was editor specific stuff for the game, that's generally how I would structure it. So don't go too overboard with it, because you can create a bit of a mess. But it gives us a way that we can partition things, that we can set up our code in a way that's going to allow for faster iteration, which is always good. Faster development times means we spend more time working on the project and working on adding in cool things, sorting out issues, rather than waiting for our code to compile. So that's really the main goal with it. Thanks, folks. Hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. It really helps out. It's really appreciated. If you're looking for the code for the project, the code is available up on GitHub. There is a link to that in the description below, and you can use this code in any of your own projects, commercial or non-commercial ones. You're able to be using it. If you've got any questions, chuck in a comment below. And if you are looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description below also. But until next time, bye.